Hello everyone. In this video we will see how we can design a GPS tracker using IoT development board. So today we have the GPS sensor module. It has an antenna. So the information related to GPS like map details, latitude, longitude, number of satellites, velocity and direction will be shown in a mobile application. So this mobile application is called Blink application. We will see later how it works. So we have a mobile phone which has a Blink application installed. It can be downloaded from the Play Store. So this is the interface of the mobile application. As we can see on the screen, we have a map. On the map, it is showing us the present location which is transmitted by the GPS antenna. On the screen, we also have a latitude, longitude, speed, direction, and the number of satellites. We can also zoom in the map. So this is the interface provided by the Blink application. Blink is an intermediate application or a server that helps us to communicate between the mobile and the IoT development board. So this was about the demonstration. Now let's understand how we have designed this and what is the program and the logic behind. So this is the full code for the GPS tracker. We have developed this code in Arduino development environment. Here we have few libraries. Some libraries are internal while other needs to be downloaded from the internet. To download external libraries, we just need to copy the name and we can search them on Google. The link will be related to github.com. So github.com is a library storage media that provides libraries. Now we can click on download. So here we can see it is downloading. After downloading, we need to add this library in Arduino. We need to click on sketch, include library, add.zip library. Now we need to navigate to the folder where we have downloaded the library. So by this method, we can add any external library. The name of the library that we are using for our GPS module is TinyGPS. And we also need a library for our Blink mobile application. So this is the library for Blink. So here we are creating a GPS object using the library TinyGPS. After that we have a map object, my map. So in the Blink application we need to define a virtual pin. So here it is V0. We will also configure it in the mobile application. After that, this is the serial port at which we will connect the GPS module with the IoT development board. This is an internal connection. After that we have a timer, Blink timer. So this timer keeps track of the time after which it will refresh the GPS details. After that we have some variables to store the information related to speed, number of satellites. Here we have authentication token. This is the authentication token that is shared between the mobile application and the IoT development board. We will later see how we can configure it. This is the name of the internet connection or the Wi-Fi router, and this one is the password. So we need to modify these two details accordingly as per our internet connection. Inside the setup function, we have initialized the GPS module. After that, we have initialized the Blink server, and we are setting an interval of 5 seconds to check for the GPS connection. So here we have a check GPS function that will check for the GPS connection. If it get any error, it will print GPS error on the mobile screen. After that, we have a loop function. Inside it, we are checking if GPS related details are available. We will read the GPS details like latitude, longitude, map details, speed, direction. After that, we are running the application in mobile. This statement will start the mobile application and it will connect to the mobile application and the development board. Here we have a display info function that will display all the details on the mobile screen. So basically, when we call this function display info, it will transmit the details like latitude, longitude, speed, direction to the Blink server, and the mobile will download this information from the Blink server using Blink application. Here we have a latitude, longitude. So by this statement we are getting latitude details, and by this statement we are getting longitude detail. So we are connecting the latitude detail to the virtual pin number V1. So these type of virtual pins are related to display the information on the Blink application. So we can randomly assign virtual pins. So here we are using V1, V2, V3 for speed, V4 for number of satellites, and V5 for direction. So this was about the code. Now we will see how we can set up the mobile application. So first we need to download the Blink application from Play Store. We have already downloaded the application. Now we will open the application. We need to create a new project. Now we will enter the project name. Select the board. The board in our case is Node MCU. We have a Wi-Fi chip in our IoT development board. We call it Node MCU. After creating a project, an authentication token has been sent to the Gmail ID. This is the same Gmail ID that we use to sign in the Blink application. So now we will go to the Gmail to check in the authentication token. So here we have got the mail from the Blink application. So here is the authentication token that was sent from the application. This authentication token we need to paste it into the program. So we will copy it from here and we will paste it inside the program. So now we will get back to the application. Now we need to add some items on the screen. So basically there are three types of items: label, value, and map. So first we will add label. The first label is latitude. Now we'll configure the label and we'll give it a name, let. So this label is connected to the virtual pin number 1, pin number 2, V2. Now we will add another label for longitude. It is connected at pin number 1, V virtual pin number 1. Now we will add a map. This map is connected at virtual pin number 0. Now we will add value display. The first value is speed. It is connected at pin number 3, virtual pin number 3. Now a value display for number of satellites. The same virtual pins we mentioned in the program. Now a value display for direction. Connected at virtual pin number 5. So now we can drag and drop the items. We can adjust their size. So now we are done setting up the mobile application. Now we'll upload the code to the IoT development board. So now we will select the tools. We'll select the board from tools menu, tools, board, node MCU. Now we will connect the micro USB cable to the IoT development board. We will also connect the GPS module. Now we will select the port. After selecting the port, we will click on upload button. So now the Arduino has started compiling the sketch. It will take some time for the compiling process. After it will upload the program. Now the program is uploading. Uploading is done. Now we will open the application. Now we will click on play the project. We have a play button on the screen on the top right corner. It will take some time to refresh. Now we can zoom in the map to see the exact location. The interface is same as using a Google map. So here is our location. This one is the present location. On the screen we can also see some details like latitude, longitude, speed, satellite, direction. So presently our speed is 0 as we are not moving, we are stable, and the number of satellite that has been used to calculate the speed and the GPS detail is 8, and the direction that we are facing is north. And we can also see latitude and longitude. This is the location detail. So this was about how we can design a GPS tracker. Using the same designing principle, we can design a pet tracker, or we can track someone position or someone location. I hope you like our video. Thank you.